Hi dears, today we can see generators and cyclic groups in very easy way. I will explain here. So let's see, let G be a group, right? So let G be a group and an element belongs to G. Then when we can see that element is said to be generator means if there exists A is equal to G. Okay, the element is said to be generator if A generated is equal to the whole group G. If this one exists, then we can say that group is said to be cyclic. So understand the concept. The element is said to be the generator and that group is said to be cyclic. Okay, if both of the case, this should be exist, that element is equal to the whole group. Let's see this example. Z4 plus circle is cyclic and what about its generators? So first of all, we can write the elements of Z4, right? So Z4 is equal to 0, 1, 2, 3. Okay. So let's take the first element. The first element here is 0. So that I am taking 0 one time, 0 two times. Here the operation is plus circle, right? So if it is into, you have to multiply 0 and etc. etc. If you add it whole times, you will get the answer is 0. So each time you are getting answer is 0, not this whole element 0, 1, 2, 3. So we can say that 0 is not the whole Z is Z4. Now I am moving to the second element, right? The second element here is 1. Okay, 1. So 1 I am taking only one time and adding 2 times which gives 2 and adding 3 times which gives 3, again adding 4 times which gives 4 but divided by 4 because the question here is it 4 plus circle, right? So 4 divides by 4, the answer in the remainder, that is the remainder is 0. So here you can see the elements 1, 2, 3, 0. The element exists here are 0, 1, 2, 2, 3. So which is nothing but Z4. So we can say this element, one element, the element 1 generated by 4 is equal to the whole group 4. Hence we can say that 1 is the generator. The element, that is important. Remind, the element 1 is the generator. Okay. If this is exists, then you can say that Z4 is cyclic. That group is cyclic. Understand the concept clearly. The element is said to be generator. This element is said to be generator. If this exists, that is A is equal to G, the whole group G exists, means the group is said to be cyclic. And not only this, we have to check for the other elements also. We just seen 2 elements. What about the other 2? So the third element is 3. Third element, which is 3, element is 3. So here 3 I am taking, sorry, third element is 2. Okay, sorry. Third element we have here is 2. So that 2 taking one time, 2 takes it 2 times, which is 4, which is equal to 0. Because in Z4 we are reasoning 0. So 2 I am taking for 3 times, which is equal to 6. The remainder is 2. Again I am taking for 4 times, which is equal to 8. The remainder is 0. And I am taking 2 for 5 times, which is equal to 10. The remainder is 2. So most of the case you can see that 2, 0, 0, 2. So here the element exists is 0, 2 alone, which is not equal to Z4. So that the element 2 is not the generator because this is not exist. A is equal to G we have, but here it is not, so that this is not the generator. Now we can see the fourth element. The fourth element is 3 in the set. Okay. In Z4 the fourth element is 3. So you can say take 3 at one time, 3 at 2 times, 6 divided by 4, that the remainder is 2. 3 I am taking for 3 times, which is equal to 9. That's equal to the remainder 1. And then I am taking 3 taking for 4 times, which is equal to 12. The remainder is 0. Here you can see. And moreover, you can take for 5 times, 6 times, etc. whatsoever. But here itself we exist the element 0, 1, 2, 3. So that is equal to Z4. So that we can say the element generated by 3 is equal to Z4. Hence we can say that the element 3 is called the generator. Element, remember this, element is generator. So the element 3 is called the generator and the group is called, if this exists, then we can say this group Z4 is called the cyclic subgroup, cyclic group under the operation plus circle. This is the way we have to write the cyclic group and the generator. So remember, the element exists, A is equal to G, this is called the generator. If this exists, this condition, this is said to be, the group is said to be cyclic. Thank you.